We're going to talk about friction in a moment, but first I wanted to talk about normal force from the perspective of the molecules in a surface. So let's assume that these red things here are molecules on a table surface. Okay? If I put a little thing on there, these molecules are basically connected by different molecular forces that I've represented like springs. It really looks like a mattress in this situation. If you put a little thing on there, it presses down on them, right? And they'll compress those springs a little bit, and the normal force on that little object will be upward, perpendicular to the surface, And a little thing compresses these a little, they push back with a little bit of force. So it'd be a small normal force. In fact, let me just rewrite that as like a little tiny thing there. Okay? Whereas if I put a big one, it squishes it more, and to compress those springs, there's a whole lot more force down on this, pushes down on the springs, and this would have a much bigger, I don't know, let's draw it like that, whoa, much bigger normal force. Okay, in other words, the surface is pushing back harder. Now, as this thing falls, as I let it go onto the surface, it presses a little, it pushes back a little, it presses more, it pushes back more, it presses, finally it ends up stopping, right? And when it ends up stopping, it'll turn out that the mg, the force of gravity, I'm not going to draw it, goes way, way down, would be equal to the normal force when it's at rest. And that's usually what we're talking about with normal force, is that the mg would be equal to the normal force in this case. Now notice, if I had something else pushing down on this, there might be another force down. If I had, like, here's a hand pushing down there. Okay, so there's the force applied from the hand. In that case, the normal force would be greater than mg. It would be equal to the force of mg plus the force of the hand. So that's how the normal force works. You really need to know the context. You need more information to figure out what the normal force is. Let's move on to friction. Friction is, again, looking at this molecular situation. Let's think of this as the surface of an object and the surface of another object. So it's between two surfaces, and let's say I push this object in this direction. Well, there are intermolecular forces between nearby molecules in these two surfaces. And if we think of those as springs, when I push this, it'll stretch those springs, stretch these springs, and those springs will pull back in the opposite direction. So the force of friction will be in this direction on that surface. The harder I push, let's assume it doesn't move. I'm pushing a table, and this is the table, foot of the table. If I push harder, bigger force, friction pushes back harder. Okay? If I don't push at all, friction is zero. So what happens is the more I push, the more friction there is. And that's a special kind called static friction. So static friction, I don't know what's taking so long to load this page, but static friction is still friction. And still friction is when the two surfaces are at rest relative to each other. And when you have static friction, there's this maximum amount of static friction that ends up being important. And I apologize that my pages are not loading. Let's skip. Okay, so let's talk about static friction is still. The surfaces are at rest relative to each other. So again, if this is this big box and I push to the right, this is my applied force, there will be a force of friction in the other direction. And I can push, if I push with 0 newtons, friction will push back. Whoop, I can't even draw an arrow for that. So there's no arrow there. If I don't push, there's no friction pushing back. If I push with 1 newton, it'll push back with 1 newton. If I push with 2 newtons and it doesn't move, it means friction's pushing back with 2 newtons. There's no total force on this thing. So this happens until this certain breaking point. So there is a max force of, and I'm going to write it as static friction. Okay? So force of friction is always going to be less than or equal to that max force of static friction. Okay? Once I get it started, I push, force of friction is constant. That's called kinetic, moving friction. Okay, so if I push with a much bigger force, it doesn't matter. This force will be the same if it's moving. So that's the difference between static and kinetic